So topic of my presentation or say paper is kidney CT image analysis using CNN. Basically, if we see through the abstract, the main thing we are doing in this paper is we are taking the analysis of the data set created by the professional radiologist, and also see understanding my CNN model I created for this data set to train. So we are, as I said, the goals are first goal is understanding cities kidney data set on which process is based on this. So the data set is made up in Dhaka, Bangladesh, where patients are already diagnosed with having a kidney tumor and cyst and normal or stone findings. Both the coronal and axial cuts were selected, and both contrast and non-contrast for the abdomen and urogram. Okay. So basically, this data set has four classes. We are divided normal, cyst, tumor, and stone, and all the both front and side cuts are visible. Okay, let's this is verified with professional radiologist, and let's see further of the size. It contains 12,446 data picks, and in which this is divided 40% are normal, and 29 around 30% is cyst, and then 18 is stone, and 11% are for tumors. And here you can see the some example pics of for the data set. So yeah, this is for the data set. Now the main thing is understanding my CNN model. So let's first go through understanding the feature and structure of the basic CNN model, and then what I have done. So basically, the CNN model is a deep learning model. It has various layers. The first layer is the input layer. The input layer generally takes the pixels or say pixels and the size, is the pixel matrix or the size matrix of a picture. As this is a gray image, so it doesn't takes the RGB value. The third 3D axis is just take the one as the value for as the gray image. Second layer is convolutional layer, which contains all the filters which helps in the feature extraction for an image. That textures, edges, corners, etc. And next is this by activation function embedded in the convolution layer only. That is the ReLU that make pos that works on positive data and make negative data all zero. And yeah, and then it is conventional layer is again convolutionally styled by pooling layer, which is which helps in reduction of the dimensions of hidden layer by combining the outputs of neuron clusters at the previous layer into single neuron in the next layer. These are useful when you want to detect an object in an image regardless its position in the image. And the next layer is the convolution layer again. So in this convolution layers, these are generally optionals. But we have all this extra convolution layer in our model that we later see. I have used two convolutional layers. In this convolution layers, we firstly put a repeat these steps 2, 3, and 4. In this, we create these layers again, the convolution layer, activation function, and the pooling layer. Then there comes the flattening. So the outputs and is taken by these hidden layers are then flattened into a single vector. And then So then it creates the data for further layers. Then this doing the same layers method, we come to output layer as the prediction, and we can for prediction we use softmax activation, and for the model training we use loss functions and backpropagation, etc. things like Adam optimizers and this same thing. Now let so this is oh sorry, this is my model for this. So as I told, I have used three layers for the uh, not three layers, sorry, five layers. Sorry, stuck. 5 to 6 layers, yes, 6 layers for and which from which fives are repeated once. But instead, I have repeated 2 layers alternatively. So so if you see the first layer, it has this in we have seen the set the size of 32 and the input and output size as 119, 198, and set the number of neurons on 32 and simple polling, and we have created two uh, 32 layers convolution layers. Then we created other two with 64 neurons and then another with 128 neurons. This and ending with the flattened layer and dense layers at the end, creating the total of about 300,000 parameters. So yeah, and these are the final results. So before going to results, I want to define each term for you guys. So going to accuracy, accuracy is nothing but the ratio of true positives plus true negatives divided by the sum of all other comparison matrix values, including true positive, true negative, false negative, and false positives. That is coming out to be 0.998 around, or say 99.84%. Then we go to precision, that is true positive divided by true positive plus false positives. And we are having the accuracy of 99.64%. Then we go for recall. Recall is true positive divided by true positive plus false negative. That is coming around 99.86%. And at the end is the F1 score. That is 2 times the precision into recall divided by precision plus recall. That is coming to be 99.755%. It's very small paper, so yeah, it doesn't have much to show or define. So yeah, it's ended. If you have any questions, you can ask, please.